Today we're going to learn how to name and some properties of alkenes and alkynes. Hopefully you recognize that all these are two carbon compounds, and the first one is an alkane. This one has only single bonds. Remember, single bonds, A and E, means it's an alkane. So this is what we call ethane. The second structure is called ethene. It actually has a double bond. So when there's one double bond present, that is an alkene, an E and E. So that's E and E represents a double bond. Now notice you see here when there's a double bond, actually the bond is actually closer. These black circles or black models represent two carbon atoms. And the two carbon atoms are pulled closer when they share. This represents 4 electrons. Now notice each carbon here still has an octet, 2, 4, and then the double bond makes 6 and 8. So it is another way that an atom can achieve an octet. Now if you notice at C2H2, this is called acetylene, or it's called ethine. Ethine has a triple bond. Now this one has a much closer bond between the two carbon atoms, and we still have an octet, 2, 4, 6, and then 8 when we count the shared pair between the carbon and the hydrogen. So how does this work? So classification of hydrocarbons. First we have alkanes. Alkanes have the general formula, it's a single bond of CnH2n plus 2. So for example, on the previous slide we had 2 carbons, but we actually multiplied that by 2 and then added 2, so we had 6 hydrogens. So the formula was C2H6. And then an alkene has a double bond. When you have a double bond, fewer hydrogens are required. So for the double bond in alkene, every single double bond that you have, 2 hydrogen atoms are removed. So the general formula for an alkene is CnH2n. If you look back once again to the previous slide that we looked at, we had C2H4 because 2 hydrogens were removed when the double bond was formed. Now the last one we said were alkynes. Alkynes are of course a triple bond, and these have the general formula CnH2n minus 2. So you should be able to recognize an alkene, an alkane, or an alkyne simply from the formula and the number of hydrogens that are present. Let's look at some examples. Let's look at this alkene and how it's named. Hopefully you recognize this is the one we had on the first slide. There are 2 carbon atoms here. Now this is a regular drawing for that. And the main thing we want to notice is we have the double bond. The main thing we want to notice is we have the double bond between the 2 carbons. If you made the ball and stick model in the lab, it would look like this, and you'd have 120 degrees in between the atoms. Next, how would you name this? Well, we know a 2 carbon alkane is called ethane, but this is actually an alkene, so we don't want to use the A and E ending. So for an alkene, it doesn't end in A and E. The name ethane changes to ethene, and once again, Ne means we have a double bond. So what if we have a triple bond? Let's say we have C2H2. This is the one we had on the first slide. It is once again not called ethane. The AN is dropped and it's called ethine. So ethine would represent there being one triple bond. So let's continue. So one of the first things to do is classify the following as alkanes, alkenes, or alkynes based on the formula. So let's see if we can do that. First one, we have C3H6. So hopefully you notice here the number of hydrogen is double the number of carbons. So hopefully you'd recognize that as an alkene. The specific name for this would be propene because it is a 3 carbon atom, which is propane, and we change it to double bond, so it's called propene. So once again, the E and E double ending, the Ne suffix tells us that we have a double bond. Next, C2H4. Once again, the number of hydrogens is double the number of carbons, and so we should hopefully recognize this as a alkene. This is, let's name this one specifically. Remember we said with 2 carbons it's ethane, so we had changed this name to ethene. And once again, the E and E ending tells us a double bond. Another example, C5H12. Now notice this one, not only if you take the number of carbons, which is 5, and you double that, you get 10, then you add 2. This would indicate that we have an alkane, that they're all single bonds, and this is what we call a saturated molecule because every single carbon is occupied with as many hydrogens as it could take. The previous two molecules would be called unsaturated. Anytime you have a double or a triple bond, it's saturated because more hydrogen atoms could be attached to that. So that's an alkane. So what would be the specific name for this alkane? Hopefully you remembered 5 carbons has the shape of a pentane, so we call it, or a pentagon, so we call that pentane. Next, C4H6. So if we take carbon and double it, we have C4H8, but then we subtracted 2, so this would indicate we have one triple bond. So this would indicate we have an alkyne. Now, what would be the name for this? Now, notice there's 4 carbon atoms. With 4 carbon atoms, we call that butane. We're going to change that to 1-butyne. Now, why 1? We want to say specifically where that triple bond is located. Let's look at some examples of these. So, first of all, C3H6 would look like this. It's propene, and so we have 3 carbons and then 1 double bond. So this one we don't need a number because we always number it from the place of the double bond, so even if we put the double bond on the other side, that would still be carbon number 1, so no numbering is required here. Next one, C2H4, we said this was ethene, so if we drew it, it would look like this. We'd have 2 carbons and simply a double bond. Notice every single carbon we're putting up here has an octet of electrons, and every hydrogen has a duet of electrons. Next one, C5H12. Now this is the pentane molecule. Now notice I'm just going to show you the sophisticated molecule drawing where we don't include the hydrogens, and this would look like just a letter M that's stretched out. Now there are actually 5 carbons here. This would be carbon number 1, carbon number 2, carbon number 3, carbon number 4, and then at the end we have carbon number 5. So that's pentane. Let's do one more. Last one we said C4H6. We said this was 1-butyne, and the drawing would look like this because really this triple bond, they put at carbon number 1, but you could also put the triple bond at carbon number 2, and that would be 2-butyne, and so that's a different substance with slightly different properties. Another thing we'll look at is a reaction of alkenes. There's one type of reaction called an addition reaction, and we're doing just that. We're adding atoms to the molecule. Atoms form single bonds to carbons formerly involved in double or triple bonds. And that's why we're mentioning it here, because we're talking about alkenes and alkynes. One type of addition reaction is called a hydrogenation reaction. In a hydrogenation reaction, the actual atom that's added is hydrogen. So H2, remember if hydrogen's by itself and it's not dissolved as an ion, we call it H2. H2 is added to double or triple bonds. An example of that is if we take C3CH2, and notice we have a double bond here. So this is what we call unsaturated. So we can saturate it by adding hydrogen atoms. And so the product for this would be simply CH3, CH2, CH3. Notice now every single carbon has as many hydrogens as it can hold, and so this is what we call a saturated molecule on this side. So the product is saturated, the reactant is unsaturated. Let's look at another type of addition reaction. This is the second type. It's called an halogenation reaction. In a halogenation reaction, what happens is a halogen is added to a double or triple bond. So instead of adding hydrogen, we add a halogen. Remember, halogens are chlorine, fluorine, bromine, and iodine. So it's going to be one of those 4 that we're adding. So we're going to basically take the same reaction, except this time we're going to add fluorine. Remember, fluorine and hydrogen are both Brinkelhoff. They're by themselves. They're going to be diatomic. And so we're going to stick that fluorine in the same place we put the hydrogens. And so the product of this reaction looks like this. CH3CHF, because the second carbon bonds a hydrogen and a fluorine, and the other hydrogen at the other end also bonds a fluorine. So we've attached a fluorine at this location and another fluorine to this location. So a couple of important terms here. One is the idea of saturated. Saturated would be the products here. Both of these products would be considered saturated because they're holding as many atoms as they can hold. Another term would be unsaturated. Remember, unsaturated refers to the ones where we have double or triple bonds. They're unsaturated because they can hold more atoms, be they hydrogens or halogens or another atom. And one last term which we haven't mentioned is the idea of polymerization. Addition reactions are often used to make longer molecules, or what we call polymers, and this is a very important concept in chemistry. So what happens is double bonds are broken and atoms are added, and so a long polymer is created. That's it.